Now we're going to find the GCF by using the dividing by primes method. And what happens for this is we divide by primes. It's an insane concept. So we typically make like an upside down box here. So looking at these two numbers, 248 and 316, think about a prime number that goes into them. I'm not the amazing Kreskin, but I'm guessing you picked 2. Totally fine. 2 goes into 248 124 times. It goes into 316, I want to say 158 times, but I'm not sure. It is! I get a cookie. And then looking at 124 and 158, we can now pick 2 yet again. The first one would be 62. And the second one, I'm pretty sure, is 79. It is! I get 2 cookies. All right. And now 62 is even, but 79 is not, so we can't use 2. 3 doesn't work, because remember, you just add up the digits. 5 won't work. 7 doesn't work. 11 doesn't work, and actually that's where we can stop. So no other prime number will work. Remember, these two are then called relatively prime because there's no number that goes into them except for 1, meaning their GCF is 1. So then the GCF of the original numbers is the product of the numbers off to the left. So 2 times 2 is 4. Great. Let's do it again for 630 and 420. So think of about a prime that goes into both. You can say 2. 630 divided by 2. Oh, I could have done that. 315. What was I thinking? And then here, this would be 210. And then 2 won't work anymore, but 5 will. 5 goes into 315 63 times. And into 210, I want to say 42 times. It just feels right. All right. 2 nor 5 will work again, but 3 will work. 3 will go in 21 times here. And here, this should be 14. And now 3 won't work anymore, but we can try 7. 7 goes in 3 times here and 2 times here. 2 and 3 are relatively prime, so we stop the process. And the GCF is the product off to the side. Again, because this is all really about multiplication, the order in which you do it does not matter. So instead of 2 starting off, you started with 5. That's fine. So we're going to have 2 times 5 times 3 times 7, which is 210, is the GCF. When we have 3 numbers, the process is the same for the GCF. Later on, we're going to do dividing by primes to find the LCM, and it's a modification of this process. Since these are all even, we can again start with a 2. We get 320 there, 140 here, and 220 here. We can do 2 again. This would be 160, 70, 110. And why not another 2? A round of 2s. This would be 80. This would be 35. And this would be 55, I reckon. We can do 5 now. I certainly hope I have enough room. I'm a little scared. I forgot how many times 5 goes in 80. I want to say 16. Oh my gosh. This would be a 7, and this would be 11. And then we stop. Because there isn't a common number except for 1 that goes into 16, 7, and 11. So GCF is off to the side. 2 times 2 times 2 times 5 is 40.